Have you all along tonight. Thank you for coming out. Should be a fun evening. We usually have guest speakers and things like that. It's going to be slightly more generic this time. There's a lot of news to catch up with, and also it's going to be fun having a look at the year ahead. So, my name's Peter. I'm the president of the Space Association. Peter Aylward's my name. Michael Adilla here is the vice president. He also coordinates all the meetings and makes it all happen. And we have various committee members. Ashley at the back there who looks after the IT. This is going to be streamed tonight, so if you've got any copyright issues or you want your royalties, just see Tim, he's our treasurer, he'll take care of the royalties. Zero, basically. So just give you a quick, well, I don't know whether anyone caught the news on Sunday, but we're going to be talking about this. This happened over at Australia, what I like to call Australia East in New Zealand. They launched a rocket on Sunday into orbit. So it's very exciting. So we'll have a full report on that a little bit later in the meeting. Quite a few Australians working out there on that, as well as New Zealanders and Americans. So tonight's meeting, we've got a fair bit of ground for you. So we're just going to give you a quick introduction of who we are, the Space Association, what we do, why we do it, and how we do it. And then we've got a bit of a look ahead. What's happening. Also talk about the venue here tonight. Once again, it's our first night here at RMIT and very happy to be here. We've also got a very exciting event coming up. It's a commercial event, but we're partnered with the organisers, so we're going to tell you all about that and some opportunities there for members as well. Then we're going to have a quick chat from James Kirby, who's from the RMIT Space Technology Association. I'm not sure whether people here maybe that's why the reason they're here, I'm not sure, but we'll give you an understanding of what they do, and we look forward to working with them through the year and learning about what they do, and hopefully getting a few of their students and people, lecturers along, etc. That should be quite a nice bit of synergy there for our group and for the RSTA. And then a little bit later on we have our feature event, which is the basically look at the head of what's happening in 2018. Quite exciting. We have a little break for networking, and we encourage you to say hello to someone you haven't met before and introduce yourself. Quite a range of people in the room, I can tell already. Then we're going to have a look at, we usually have a retrospective of some description, a lot of 50th anniversaries, etc., etc. We're going to have a look at the career of John Young, who was an Apollo astronaut and very accomplished. He recently passed away, so quite an amazing story. Quite an amazing gentleman. And then we're going to have a roundup of our planetary and space science news with Andrew Rennie, who's our resident planetary person. So there we go, that's kind of look at tonight. So once again, tonight obviously the 4th Monday of January, so our formula has, or will be, for the rest of the year, we hope, will be the 4th Monday of each month. With the exception of December, because the 4th Monday of December gets into the silly season, so we'll probably look at December 10 or 17. We'll have to talk about that as we get closer to that time of the year. So if you forget when it's going to be on, check our Facebook page, etc. But think about that the 4th Monday of the month. So what do we do as a group? We have meetings such as what you're experiencing tonight, where we have guest speakers, roundups, etc. Of space news. We have member activities. There's actually one of our members over in the US at the moment, and he's hopefully trying to see the SpaceX Heavy launch. So if he can see that, hopefully we'll get a first-hand update from him on that. As I mentioned, we do live stream our meetings, and we also have them available for vidcasts, which you can look at later on. So all of last year's meetings are up there. So if you're interested in a particular subject or a particular speaker, you can go there and watch that. And we also run a radio show called The Space Show. That goes to air every Wednesday night at 7 p.m. and it's on 88.3 Southern FM, but it's also live streamed. We get a lot of listeners from around the world actually listening to the live stream. And then the key interviews and content that is incorporated in the show is actually incorporated in the podcast for later listening. The actual show itself is kept on the website for 7 days after it goes to broadcast, so it's up there from Wednesday night, and then it's there for the following week to listen to the entire show if you're interested. So what we do is we obviously try to promote public understanding of space flight, etc., and once again we have updated news. We also have special guests in, and taking over this gentleman here. He walked on the moon. We're going to have news about him later on as well. We've also run a meetup group, which maybe some of you actually came on to as a result of the meetup. It's a sort of what we've created is an Australian space network. So the idea is it's not just a news about us, the Space Association. We have news from the Mars Society and National Space Society and whoever else is out there. It's a sort of a catch-all. Anything that's related to space, except for the Korean national, we can't say miss that, is usually put in there. And if you find anything, if you hear about something that's going on, please contact us through the contact details there, and we'll put it up on there. Just really a catch-all network, a catch-all directory. So if, for example, you're going to Sydney next week and you think, well, what's happening in Sydney? It might be a space thing, and you can go to the network and go and see if there's something happening up there. And this is what the site looks like. So once again, you go and you log in and you can see what's going on there.
Peter, do you have to log in?
You don't have to log in. Sorry, you're right. To get updates, etc. But you can just go as a viewer and not log in. Great account. Good point. Thank you, Andrew. We also have special events. We've had different sorts of things happened over the years. We had some authors and movie premieres and that type of thing. And we had an International Space Station flight director. You okay? Did you fly?
Yeah.
Okay. Fantastic. And we also have movies and that. So I think there's a few things coming up there as well. This is an event we partner with different groups as well. Not only tonight, we're partnering with the RMIT Space Technology Association. We've also partnered with Engineers Australia, Royal Aeronautical Society. So we try to link up with people with like interests, etc. So yes, this guy's fascinating. Event size. So coming back to tonight, for the people who are familiar with the Space Association, we have formed this partnership with the RST. I've put in group sort of association, so RSTA. They're looking after the bookings and effectively our hosts tonight, so we're very thankful for that. We'd like you to introduce. Is there any members of your group here?
Not today.
No, not today. There will be when school's back, right? Okay, we're being there for lunch. Yeah. So once again, we do look forward to working closely with these guys and giving them some benefit and content as well as taking some benefit from them. So if it's possible tonight, at the end of the night, if you could see Ashley and Mike about helping to pack up, that would be wonderful. There's a fair bit of gear to load out. And let's look forward to having a good year. Now, some fantastic news. The Space Association has just concluded an agreement to become an official show partner for an upcoming movie premiere, which is called Mission Control, The Unsung Heroes of Apollo. It's a documentary film about you've all seen on TV, Apollo 13, Mission Control, all that sort of stuff. This is a movie about that, and it's a documentary. It's supposed to be fantastic. The great thing about that is that it's actually coming out in conjunction with the tour of an astronaut, Charlie Duke, who walked on the moon. This is actually him on the moon. This is Charlie Duke. He walked on the moon in 1972 on Apollo 16. And he is a really lovely guy. We've met, several of us have met him, and a very nice guy, fascinating, smart, and a real passionate space person as well. And so we're looking forward to having him. So they're going to be showing the movie, then they'll have a Q&A with him. So it should be really a great night. So it's on here in Melbourne. So we're partnering once again with these guys. Haviland Digital and Live on Stage are the producers of the show. And we've got Professor Lisa Harvey-Smith is sort of the host of the show. I don't know whether you've seen her. She was with Buzz Aldrin a little while ago as well. She's a great moderator. And basically these are the dates around Australia. Obviously May the 2nd is probably most relevant for the people in this room, at the Astor Theatre. So we love the Astor Theatre. We've had a few things there and we love the venue. So tickets are on sale now for that. And they do have meet and greet packages available. If you're interested, they're very limited number. So if you're really interested, want to meet someone's walked on the moon, go ahead and do that. And once again, if you're friends or you're going to be in interstate, those dates are around the country. So, what does that mean for us? For the Space Association, obviously we're fascinated and passionate about space and exploration, etc. We believe our members have got a lot of interest in this event. And so what we've done in partnership with the producers, we're having a competition. So if you're a paid-up member of our association, you go into the draw to win one of 2 tickets in each of those cities. So they're worth $85 approximately for a ticket. So as long as you're a member by April the 3rd, midnight April the 3rd, you'll automatically go into the draw. What we would encourage people to do if they are members, but there's no way they could get along to the event or would not want to be interested in going, just let us know, drop us an email, or we might have a system set up, I'm not sure we did that last time, of nominating. But basically all you have to do is be a member of the association. So we're going to kind of geo-locate it, so if you're in Victoria, you'll basically go to draw for the Melbourne event, Sydney, ACT, etc., etc. So membership for the association, for those who are not aware, the concession membership $25 or pool membership is $50. And basically that's an annual membership which goes from the date you join. So if you log on tonight and pay your money, you're a member until 12 months from today. So this is Charlie in Mission Control. People, well, most of you, well, half of you look like you're old enough to remember the moon landing. A lot of you don't. But anyway, you might have been around. People were familiar with it when they were landing on the moon, that last few minutes going down to the moon, and there was a guy talking to the astronauts, and he said, when they finally landed, we've got a bunch of guys about to turn blue, we're breathing again, thanks a lot. That was Charlie. He was in Mission Control. He was talking to Neil Armstrong and Buzz Aldrin as they were descending down to the moon. So that was him. So he's got fascinating stories. So this is my propaganda piece. So membership of the association. If you're interested, you can join their website, or follow links to our website, or you can see Tim over here. He will take your money in detail. Yeah, very great. So yeah, have a look at see what your status of membership is. Sorry, James. This is a handover to you. So I'm going to run that again because I'm. Anyway, without further ado, we're going to hand over to James Kirby from the RMIT Space Technology Association to give us a bit of an understanding what they do.
Okay, good evening everyone, and welcome to RMIT. Just a couple of things that didn't show up very well. A couple of things that I wanted to show you. I know that this is the first time a few people have been here, so I'll bring up Google Maps because that was where the parking is. In fact, can I get a show of hands who drives into the city, or who would drive to the meeting? A few? Okay. So, on the map, we are just up here. Now, there's a whole bunch of free parking just after 6 o'clock, and that's up on Cardigan Street, just up here. So you'll find both sides of the road free after 6 o'clock. All the way up and past this park up here, even some of the side streets. And just right at the beginning of Cardigan, if you don't want to walk too far, there is a car park that is low cost if you get in there after 4:30. So if you're driving and parking when you come into this meeting, that's where it is, just on the corner right there. If you're public transport, we're right next to Melbourne Central Station. So yeah, I'm sure many of you came through that station before, and it's just a short walk up Swanston Street. Toilets, if you haven't found them, are just outside, right near where the lifts are, and they're the same on every single level. So if we do happen to change room and we go to a different one in some of these following meetings, you'll find them all in the same spot just over there. And if you want to get any food before the meeting starts, there's plenty of cafes and restaurants all around the university, and especially once semester starts up again in March, you'll find a lot of stuff open within the university as well. So as well as that, I just wanted to give you a little bit of a quick rundown as to what we do. As Peter said, we're basically hosting SAA hopefully for the rest of this year. But we also have a group within the uni. Really what we're focused on is creating links between industry and academia. So we do that in a few ways, from a research and development perspective, also looking for internships, opportunities for the students within RMIT. So we're really there about generating interest in the space industry and providing opportunities for the students as well. A couple of the more hands-on things that we do, we have a school program that we run where we do water rockets. So we go around to a lot of the schools focused on the Year 8 curriculum, where we take them through a whole day of learning basic physics, building water rockets, and then launching those water rockets on the day as well. So we have a lot of our students there who volunteer for that program. We're doing some work with additive manufacture of propulsion system components. So that's a research strength, I guess, of RMIT. They do a lot of additive manufacturing. So we partner with them. And we also, for a while, we've been building some of the model rockets, and we're now sort of progressing towards the larger scale model rockets, I guess. So at the moment, we're trying to partner up with EEE so that we can get some memberships, but a lot of our students will have some workshops there where they can build those rockets. So that's some of the hands-on things that we do, as well as being facilitating everything else. So thank you for your time, and I'll hand you back to Peter or Michael.
As I mentioned earlier, John Young passed away. What was his age again? 87 years of age. So I spoke to Charlie Duke a few years ago when he was here and asked him about John Young. At that stage, I think he was suffering at that stage from Alzheimer's disease, and it was not community to many people, so he had been in ill health for a number of years. But he did fly another mission, as they alluded to there, on Space Lab on the shuttle. And my recollection is that they came very close to having a disaster on that mission, because one of the engines on the shuttle, the ABUs that runs the aerodynamics, actually had a fire just close to landing and in the bay at the back of the spacecraft, and they reckon that if that fire started a minute or so earlier, it would have burnt through a lot of the control pipes and lines and things and electronics, and they would have lost control of the shuttle. So he dodged a bullet there. Anyway, a sad passing for John Young. We're going to take a little break now for about 15 minutes. We just get it set up for our news roundup from Angelo, who's just arrived. We do apologise for the sort of shuffle in the schedule, but once again, teething issues, finding where to park, where to go to for the venue. So please feel free to stand up, walk around, introduce yourself to some of the emails, and we'll be back at 8 o'clock.
Okay, so Angelo is our resident space news guy, news space, etc. So we're going to have a half an hour with Angelo to look at all the upcoming space news.
Okay, so tonight I thought we'd take the opportunity to talk about what's going to happen this year. If you thought last year was pretty good, this year will be even better. So I'll start off and go through some of the missions. The 2018 highlights to watch out for. just about put all the launches that I know about on here, but some are significant. And now the month kicked off pretty well, but the real standout was last year's SpaceX performance. Yes, I am a fan, and I reckon they're terrific. But they, as I will explain, they probably hit a bit of a hitch this year, as has Boeing, but nevertheless, 2017 was a really big year. They had 18 launches with all landing attempts successful, and they've now got 3 operational launch sites. They are also trying this year, they actually tried to get about 24 launches in last year, they only got 18. Not a bad effort nonetheless. They were trying to get, are going to try to get 30 launches in 2018. So it's a pretty ambitious launch rate, but pretty exciting to watch. The year started off with SpaceX Zoomer. Now, I don't know how much you know about this, but nobody knows. Well, nobody knows very much about it. No one even knows what US government department it came from. The story is this, that it was built by Northrop Grumman. It was the payload fairing on which it was contained was Northrop Grumman. It sat on top of the payload adapter. Okay, it was sitting on top of, so the fairing was SpaceX, so payload adapter was Northrop Grumman. It launched, and then there were all sorts of rumours about it being lost in the ocean. And this was a really high-profile, $1 billion something, spy satellite or test vehicle. You can speculate as much as you like on this one. But a few days later, the deputy CEO of SpaceX announced it wasn't our rocket. Our rocket performed perfectly. We've analysed the data. It's worked fine. Had that rocket failed to put the satellite in orbit, they would not have been proceeding on with the launches that are about to come, nor would they be proceeding with Falcon Heavy. It's an interesting thing. No one's been sued yet, but the next thing you probably see is Northrop Grumman in front of the judge.
If both stages on the rocket were successful, the second stage and the payload would have gone into orbit, or would it have, what's the process?
I'm not quite sure if the second stage actually, it must go into orbit, but they deorbit burn. However, if there was a way to release the satellite, because the story goes that it was still attached to the second stage and it went into the sea. But this is all speculation. No one knows. For all we know, it's still up there doing its job. It could have been a hypersonic vehicle that re-entered the Earth. Nobody knows anything. It's all speculation that it fell into the Earth. Anyway, so the year started off well. I don't want to labour on this one, but we don't know very much about it, and probably what I've said is as much as anyone knows. But it's all speculation. However, what I do know is SpaceX rocket, they haven't been stood down. They're still proceeding, and which to me confirms it wasn't a rocket problem. Okay, moving on. There's been a number of other rockets. Long Marches have launched. Interesting, the Indians launched PSLV-C with 31 satellites the other day. That wasn't a bad effort. Epsilon, Japanese rocket, Long March, launched more satellites, a missile warning, and then of course yesterday, on our side of the world, we had from New Zealand, Electron. So I'll come back to that. Coming up, we'll have an Ariane 5 launch, we'll have another Long March, Falcon 9, as I said, that'll be the end of the month, no problem, they'll launch that. And of course, we're all waiting for Falcon Heavy. Now the Falcon Heavy will be probably, it's twice the capacity of any flying rocket at the moment. It'll have 27 engines on the bottom, all igniting at the same time. It'll be something else to see. They've been trying to do the static tests at the Cape, as you might be aware. Problem is that now they've got a government stand down, and government people have to be around the rocket before they will static test fire. But it was still scheduled for the end of the month. It looks like it'll go into February sometime. But it'll be launching Elon Musk's Red Roadster, 2 not orbiting Mars, to the location of Mars orbit. Okay, so we'll just send it out there and then go into heliocentric orbit, I presume. Andrew, would that be about right? I forget exactly how it'll pan out.
It's not going to Mars, it'll go into a home and transfer orbit.
Okay. So it'll only go out to the distance of Mars orbit. Anyway, the other one I saw, and I haven't confirmed this, was an Electron Test 3. I think there won't be a Test 3. I think it'll go straight into operation, and that'll be coming up in the next few months. Okay, moving on. I'd like to show you the video, if you haven't seen it, from yesterday's launch. Here we go. Oops, back.
I'm trying to launch the video.
It worked good on the computer before. There it is. Yeah, not there. Up. That's it.
Oh, that's right. We had the same problem with it. It doesn't have a flash thing.
Gosh, you're joking.
Did you not run it?
I ran it. I ran it at work.
Yeah. No, it's not better. You got set video? Did you have?
We've got another version of it.
I've got it.
I've got a short version, isn't it? No,
Hang on, give it to me. It's on the desktop. Here we go.
But it's a manual latch, it replaces the automatic latch with automatic latch.
Sorry. Yeah, so we're not going to be able to show the videos.
Listen to space program.
Tonight I didn't pick my computer.
No, I've been away in South Australia. No.
Andrew had the space program. Started early apparently because of some connection as far as starting early. And the next programmer after him, I think Purple Haze or something like this, they couldn't quite get the comms right. So Andrew had to stay for another 40 minutes filling in.
Normally you can double click on the file and it will play, but in this system you've got to go into the sub files, you've got to go into the software that plays it and then find the film you want to show in there.
So launching the video of the launch is
Something
something.
to do with me.
Sorry guys. Can you get the shot on there? That's Ashley. Go on, do you know how to drive a Windows machine?
Skip 24 minutes.
Yeah, I know. That particular file was 24 minutes. The one I had in the embedded PowerPoint was 3.
Yeah, and that's the one I've got here.
I like this chip. Or did you do your exams?
And 9, 8,
Did you hear the Kiwi voice there? Jet lag.
Andrew, the rocket should be coloured black. Red.
South Africa.
Max time and pressure approaching. Max time and pressure.
See the high altitude wind shear.
Altitude 20.
It was borderline as to whether or not they could launch it.
They did pick the windiest part of New Zealand to build a launch pad.
Staging.
These are high altitude winds.
Staging embedded. Stage 2 propulsion nominal. Vehicle is stable.
Following novel item track.
Southwind is above horizon, awaiting S-band shutdown and emerge of startup. Fairing separation.
Andrew, these were all CubeSats, weren't they?
Yes.
All three. Yeah.
Seconds. 5 seconds. Vehicles orbital.
We've got confirmation of payload deploy orbit insertion, which wraps up the initial part of our mission with a successful insertion into orbit.
Okay, let's go back to the presentation. Okay, shame I can't show this video either. That's Falcon Heavy. It puts in about 54 tonnes into low Earth orbit. The Saturn V, by comparison, was, someone can remind me, in that sort of 150 tonnes, 140 tonnes into low Earth orbit. So we're still a way to go before we get to that capacity, but it's pretty good nonetheless. Okay, February. We've got nothing really spectacular for February. There's a whole series of Soyuz, long marches. The Japanese are quite active. Chinese, of course, very active. And of course, Falcon, 9, and of course the Indians. In March, there's a series of, we've got Soyuz coming back into to the space station. And we've come down to GSLV Mark II, Indian, Lunar Orbiter Lander. So that's something to look forward to in March, and you know, testimony to their space program that they can actually. Exactly. So Andrew will talk a little bit more about it.
Is that a Google X Prize thing?
No. No, that the Team Indy has basically couldn't get the funding and has pulled out of the Lunar X Prize. I'll get back to that in a sec. Then we come down to a few other launches, but we've got Electron. That launch, the March launch, is I think first of the commercial launches. So that's pretty good. And it's one of many small lift rocket launches in development around the world at the moment. So
Who's running that? Who's leading that?
that's actually it's an American-New Zealand thing, believe it or not. Andrew, can you elaborate? Rocket Lab, who are they?
Okay, Rocket Lab was formed by a guy called Jeff Beck, who used to work for Fisher and Paykel, making washing machines and things like that. And he had the idea of rocketry and stuff. And they did some work in New Zealand, but then they needed the technology, and so they formed a company called in America. So most of their materials are additive mission. What's that?
3D printed.
Yes, 3D printed. Okay, in Huntingdale, in California, and then their rockets and so on are shipped over here. So it's a joint American and New Zealand company.
And if you read about it, it's really high technology. The carbon fibre bodies, the 3D printed additive manufacturing that they use of the rocket engines, it's pretty amazing. They've really done a good job at optimising and reducing the costs. Even though the cost per kilogram to launch on Electron is really quite expensive compared to, say, SpaceX. The thing is, though, it's a boutique launcher, which means it'll get you into the launch position you want your satellite to be in and not be a secondary payload to someone like SpaceX. So it's pretty innovative, and hopefully it'll get, because it's one of the first on the market, because it'll lift up to 250 kilos into low Earth orbit. Because it's one of the first on the market, it'll probably start to generate that business.
How much would 250 kilos cost to put it up in?
The last time I heard it was something like about $33,000 a kilogram or something. It's pretty expensive. Oh yeah.
$6 million launch.
Yeah. But again, 250 divided by 6 million, you can work it out. The next thing you'll see in March will be, and these are to be advised, Virgin Launcher 1. That'll be like a Pegasus rocket, if you remember. They drop it off the bottom of a in this case, it'll be a 747, and this will be Virgin Galactic. Will launch again the small satellite class. Will launch rockets off a jet. They're not the only ones that do it. Of course, Pegasus does it off their what is it? L1. Anyway, it's a different aircraft. And then we've got Strato Launch that's coming up with a really monster of an aircraft that'll be flying this year as well. And we've got Pegasus, of course. I'd love to show you this. Moon Express. Because of the Electron launch, there is it's unlikely, but there was a small possibility that they could launch Moon Express to the moon, and they're part of the Google X Prize. Okay? The end of March, there's been no extension to the Google X Prize. The end of March is the deadline. It was to be lifted via the Electron. They have to obviously reduce the weight of the Lunar Express lander because the Electron can't get that 250 kilos to the moon, can get less than that. But the idea is that to win the Lunar X Prize, you drive 500 metres and you beam back high definition video, and if you can achieve that by the deadline, you win $20 million. Not a lot of money in the space game, but you know, it helps. But this guy, the guy who's running Lunar Express, he's set, whether Lunar X Prize or not, he'll still is building a vehicle to transport payload to the moon, commercial. So there will be a launch I don't know when, possibly this year, maybe more likely next year, to bring a little telescope onto the lunar surface. But that's a modular, that's a modular system, and it can be adapted to your payload. So it's pretty cool. Moving on. In April, we've got Falcon 9, again, the crew resupply, 14. We've got the Falcon 9 Block 5. That's the version of the rocket that is meant to satisfy NASA that SpaceX can actually launch men to the space station. There's one little hiccup to that. In September, was it September? I think that's when it blew up. What they've got is they've got these helium tanks that sit inside the rocket, and the helium provides the pressure to pressurise the booster so it can fly. It's made of carbon fibre, and the way SpaceX load their fuel caused something to happen with the carbon fibre where the oxygen delaminated it, and maybe the friction of the delamination set the thing off and the rocket blew up on the pad. NASA is not comfortable to launch the Falcon 9 Block 5 version with that still in place, which means they were going to be launching men to the space station by the end of the year. It looks like it'll probably get pushed into 2019. So interesting events are happening. And the other thing that NASA said is in order to qualify for man rating, the Falcon 9 has to have 7 successful launches first of the Block 5. So it's a tall order. But nevertheless, they will be launching in April the Block 5 version of that particular rocket. And it's all based on man rating, having redundancies and various subsystems to ensure the safety of the crew. In May, the big one, which Andrew will also talk about, is Insight to Mars. So that'll be a lander. Andrew, you'll be talking about that one?
Just briefly, yes.
Briefly, okay. So that'll be another good one to watch. So it's kind of, this year is the year of the moon, but we haven't forgotten Mars either. So we're still going for Mars. Next, in June, the one to look out for is, there's another Falcon Heavy launch, and that's going to launch a US Air Force tech demo, and SpaceX, because it wants the US Air Force business, will do everything in its power to make sure that works. And you've got various other launches. Going into July, the one that hopefully Andrew will talk about again is the Delta IV Heavy will launch the Parker Solar Probe, which is a probe, as I understand it, that actually gets to the atmosphere, the external atmosphere of the sun, which is pretty amazing.
Not that close.
Not that close? Would melt? But will you talk about that, Andrew?
Not Parker, I'll do the European one.
Okay. The other one, again in the small class launcher categories, Vector R, supposedly the first orbital flight of that particular rocket. I'm dying to see that one. Going into August, we've got the Atlas CST-100, unmanned, first test, and that's the Boeing. When Boeing won the contract, as did SpaceX, to launch men to the space station, Boeing received $4 billion. SpaceX got $2 billion. So one could expect, because of that kind of money, they are probably the lead runner at the moment. And they've got an Atlas which is, they've just about certified that for manned flight as well. So they're going pretty well, even though, again, they had a recent review at NASA, and even Boeing aren't through the hoops yet. They've got to do a lot of work to convince NASA that they can actually fly men safely. But in August, we might actually see, I suspect that'll slip a little bit, but this year we'll see an unmanned version of the CST-100. Falcon 9 Block 5, Crew Dragon, unmanned, August, unlikely. It might happen, but unlikely. Moving down to Launcher 1, a number of satellites, so it'll be presumably operational. September, nothing of significance there. The Delta IV Heavy, always good to see, especially when it fires its engines and looks like it's about to be burnt up because all the cork on the side of it sets a fire, or the insulation. It's a pretty amazing thing. Going into October, we've got the Ariane 5 Mercury probes. Are they actually 2 probes?
Yes.
So there are. There's Japanese and European. So that'll be good to watch too. There are orbiters, actually. Even better. Moving into November, supposedly we've got the CST-100, the Boeing Starliner, manned demonstration flight to the space station.
That's 2018.
I've got 2018 there, but yeah, I'm with you.
No, November 2017.
Oh, sorry, it's 18. No, it's 18.
Just seeing you're paying attention.
In December, looking forward to these ones. Long March 3B, Changi 4 lunar lander to the dark side of the moon. So this will be awesome.
Has it got lights?
Sorry?
Does it have lights, you say?
Anyway, this will be pretty good. And then we've got another Block 5 that was scheduled for the manned version of the Crew Dragon. Won't happen.
So how do they know if it's successful and fast on the moon?
I don't know what relay. I think that's an orbiter. I think there's an orbiter.
I'll talk about that.
Will you talk about that? I think it's an orbiter and lander, but let Andrew explain a bit more on it. Okay, moving on. Other things that we have to look for. No one said no yet to the Falcon Heavy circumlunar manned flight. No one said no, but I don't think it'll happen, but it was scheduled to happen this year. The idea was 2 very rich paying customers are going to get a trip to basically, I think it's a replica of Apollo 8. Go to the moon, swing around, free run trajectory or whatever they call it, straight back to the Earth. So, don't think it'll happen this year, but he's still got it on the books. And he also wants to prove to NASA, because he's, as you know, Elon Musk has been Mars focused, but now all of a sudden he's starting to become moon focused. Why? Because NASA has committed to getting the Americans back to the moon. And he wants part of the business. Why not? Changi 5. Now, there was a rocket failure last year of the Long March 5 that blew up, and that put doubt as to the launch date. But that is a Chinese lunar sample return, and they're just going to reschedule the date for that. So again, the Chinese are, they've made no bones about it. They want to get to the moon, and they're doing everything they can to get there. We'll also see during the year sometime, I don't know when, we'll see SpaceX actually launch one of its 3 flight-proven boosters to do an in-flight abort. So what will happen is you launch the rocket and then you will abort the manned Dragon off it to prove that it actually does work. There's another thing here. I put Ark in space. Don't know how serious this is. If you read some of the literature, some people take it as a bit of a joke, but they were developing a rocket with what's called linear aerospike engines, and they are very efficient space engines that can be used in space and the atmosphere, because if you see the normal engine that you see on a rocket, most of those are optimised for either the atmosphere or space, but they don't have both, whilst the linear aerospikes actually adjust accordingly. And other things to watch, the NASA Space Launch System, still well into development now. The Orion capsule, the service module, the European-made service module, the Kennedy Space Centre facility is still being upgraded. There was talk of having another launch tower. I haven't heard any more, Michael, unless you have, that they were looking at building another one to, again, accelerate the ability to get this space launch system. The first iteration of this thing, which is the Block 1, I think it's the Block 1, whatever its first designation, will be able to get 70 metric tonnes into low Earth orbit. So it's already going to be more powerful in its first iteration than the Falcon Heavy. This rocket is in fact a Saturn V class vehicle. In its final iteration of its development, probably around about 2025 to 2030, it'll be able to lift 150 metric tonnes into low Earth orbit, which is pretty good. It means you can lift big payloads to the moon and to Mars. So pretty good. We'll get more engine testing They are building the rocket, the components. They're testing the core stage in Mississippi at Stennis, and we'll have Exploration Mission 1, which will occur in 2019. Other things to watch out for: Strato Launch will fly its huge transport aircraft. Virgin will, I mean, they keep talking about bringing people into space this year, but I think you'll be looking next year. Blue Origin will continue to fly New Shepard. They're talking about next year for actual paying tourists into space. So be a good ride, I could imagine. The Google X Prize will expire in March. I don't think that'll, unless they extend it, no one's going to win that. New small satellite launches. I read a recent article that said there are 38 small satellite launches in development at the moment. So everyone's just gone crazy. The Chinese are into it, the Japanese are into it. I don't know about the Russians. Sorry?
New Zealand?
Well, New Zealand, you know, first cab off the rank. They've done very well. And again, like I said, 2017 was a big year, 2018 will be a bigger year, and 2019 will be even bigger. So that's what we have to look forward to. That's the Space Launch System with the Orion capsule. These are 5-segmented shuttle solid rocket boosters. The shuttles have 4 segments in it. This has got 5. And these engines are the RS-25s, which were used very successfully, probably one of the most reliable engines, you know, built, because they launched how many shuttle flights? 100 and lots. And those actual engines in the first few missions will actually be ex-shuttle engines. But this is the, I think it's the E version of the engine. They're going to a D version, which is a mass-produced version that they will just drop into the sea and discard. But interestingly enough, there's no reusability of this. So, as you know, everyone's now focused on reusability of rockets, driven by SpaceX, but this is old style, you know, launch and throw away.
They're not doing the SRB?
Sorry?
They're not doing the SRB?
No. They will drop them into the ocean and that's it. That's it. That was a video, but can't play it. Always worth a try. Nah, what a shame. That was a good video too. I can, but too much mucking around. All right, that's it. Thank you.
Hi, I'm Andrew Rennie. Yeah, is that coming through? Be closer.
I think so.
Is that coming through? Right. I'm doing the planetary side of things, but having spent about 5 hours on Saturday watching my stream come in from Rocket Lab, and then again, fortunately only half an hour on Sunday because it went off pretty much on time. I was listening, of course, to what they're saying, and of course you get used to the accents. You already heard Jeff and his Kiwi accent during the countdown, which you've never heard before, have you? How many of you have heard a Kiwi accent coming from Cape Canaveral? Okay, or Karoo, or something like that. Okay, so we heard it. Well, here is a little snippet from Saturday. Now remember, they had the hold because a ship, 2 boats came into the area. And then high altitude winds limited the launch, and then they had a problem, an electronics problem with one of the cameras on the rocket. Anyway, listen closely, very closely, to the clip that Michael is now going to play for us.
Flight VMS mission coordinator.
Go ahead, PMS.
Do you want any hold points?
Say again.
Do you want any hold points?
I did get you. One more time.
Do you want any hold points? As in, do you want to hold that T minus 18 or 20?
I never want to hold in the end.
Well, ask you.
This is Mission Control Auckland. As you can see, the clock is still counting.
Okay. And you saw the American guy come in. Okay. You can't understand it. Yes, I had the same problem when I was in America. I was from Auckland. And they say, Oakland? Oakland? In California, in California.
Northern California.
And, where it is, Oakland. Okay, concept development has been approved by NASA for some planetary missions. There was a competition. There was a competition to get approval for this, and so there are 12 in the competition with the idea that these planetary missions be launched in the mid-2020s. The first one approved for development, this is not actually going to fly yet, they haven't chosen the one to fly, is the Comet Astrobiology Exploration Sample Return, and it's going to go to Comet Churyumov-Gerasimenko. And you say, how come he can say that name so fast, Churyumov-Gerasimenko? Well, I've been saying it for years, because guess where it went to, Peter?
Where did it go?
Guess why that's famous? Because Rosetta went there. Okay, so the aim is to determine the origin and history of particularly that comet, but other comets as well, and to see how they contributed to the early Earth. There's a question still outstanding as to whether the water in the Earth's oceans came out of the Earth or whether it came from cometary bombardment. And that question, even though we've had some comet missions now, is still not finally resolved. This project is known and led by Steve Squires. And you say, I've heard that name before. Yeah. Mars Exploration Rover, Spirit and Opportunity, still roving around Mars. And if this gets approved, if he gets the nod to do this mission, he says he's going to step down as the principal investigator of Opportunity. Of course, Spirit has now finished operating. It'll be managed by Greenbelt Space Flight Centre. That's an idea of what it will look like. And you say, hey, that looks a bit familiar. Yes, based on OSIRIS-REx with a sample collector, based on Hayabusa, which collected samples, and Hayabusa 2 is en route to a comet, an asteroid, so to collect samples. So it's going to collect samples from Comet Churyumov. And so the heritage is based on those missions. Why choose this comet? We would have been saying, why don't we go to a different comet? Well, the answer is if you want to land on a comet, it helps if you know the gravitational field, so you can work out where you're going to hit. It makes your approach, landing and departure predictable. Remember when Philae went down, they had already been in orbit round with Rosetta for quite some time before they chose where to make Philae. They had time to map the gravitational field. So the land, and of course this mission will be just a lander, it won't be it'll be a touchdown and sample grabber, but it won't be studying the comet in great detail. So you can select the landing site in advance, even from here on Earth, with what we know from Rosetta. And it will complement what we found out with Rosetta. So it's not a repetition, it's an addition to. And of course, that comet is relatively easy to get to compared to some of the other comets you might choose to go to. The other mission up for suggested, for investigation now is Dragonfly. Now this is a bit fascinating concept. Go to Titan with a drone-like rotorcraft or lander. It's be a dual quadcopter, And the idea is that we're about to land, sample, and then take off and land and take off and go to different places. Over not just a few metres, but hundreds of kilometres across Titan's surface. So you're about to investigate the lakes, you're about to investigate the mountain areas and so on. And that's what it would look like if it is approved. The science: to investigate Titan's organic chemistry and habitability, monitor atmospheric and surface conditions, to image the landforms, which they've been mapped by radar by the Cassini mission, but we don't really have full detail of it. And we also perform seismic studies. Now, the Dragonfly project is going to be led by Elizabeth Tuttle from Johns Hopkins University, and APL is providing the project management for that.
Andrew, gentleman had a question.
Sorry, is the environment of Titan, is it similar to Earth, like the geography, sort of the hills?
Yes.
Is it? It's like Earth?
Well, yes, except and I got more on my other presentation. It's basically it's rock of ice, so it's wood ice rock, overlain with organic materials, and with some lakes of primarily methane and a few seas. Is the correct word. So what's going to happen there is NASA is now funding this through this year, and then plans to select one of the two investigations early next year to continue on with the subsequent mission phases. And of course, being a particular program, it's New Frontiers program. The New Horizons is one of these. It's capped at $850 million. So so that's what they're doing. Also, they approved some technology development things. It's all selected by a competitive peer review process, and to prepare them for future mission competitions. The technology developments had to be chosen from that list there, and these are the ones they chose to put some money into. The Enceladus, life signatures and habitability, and the Venus in situ composition investigations. The Enceladus mission is to figure out if we're going to land on Enceladus and find out, what's really down there. How are we going to prevent contaminating what could well be a planet? I call it a planet, like a moon, 500 kilometres across. That already might have life on it already. So how do we prevent contamination on that? Notice Chris McKay. Now he's a biologist. He's been working in astrobiology for many, many years. Be managed by Goddard. The Venus one, to develop a camera that will operate on the surface of Venus. And remember the harsh conditions on Venus, 90 atmospheres pressure, come down through sulfuric acid, and the temperature's around about 400, 500 degrees, something like that. Okay. Right, now, the next thing is what's happening this year in planetary stuff. So that's the planetary news one. Thank you. Excellent. So here we go. First on science results, and then we'll talk about some of the missions that are coming up. Cassini has found that Titan has a sea level, like the Earth does. And the seas, of course, are made of hydrocarbon, mainly methane, liquid methane. And the body of Titan is made of water ice overlain by a layer of organic material. And that serves as a bedrock in which these lakes sit. And of course, if you go deeper down into Titan, there's possibly liquid maybe a global ocean and the rock and stuff down below that. But the interesting finding here has been that the Titan seas follow a constant elevation relative to Titan's gravitational pull. These results, by the way, were published just before Christmas. Now here is the altimetry from the Cassini mission, and you can see that they follow pretty much the red line, which is the natural geoid. That is where, if there was a global ocean, where the liquid would naturally sit, held by gravity. So yeah, so that's the part of the main finding. Now the smaller lakes on Titan are interesting in that they are higher than Titan's sea by several hundred meters. And they appear to be connected under the surface by something akin to an aquifer system on Earth. So the hydrocarbons appear to be flowing underneath the surface, and that provides a levelling out. There are some dry lakes on Titan, which are, all the dry lakes are higher than the lakes that are filled, which suggests that they've drained out into the lower lakes. There are no dry lakes lower than the liquid ones, and the explanation for that is, well, if there was anything lower, the methane would flow down into them. So there's a system there between them. And Cassini, with the radar, was able to measure Titan's geoid, and the shape of the surface is exactly what would be explained by gravity and the rotation of the moon. Now, the Titan lakes exist hundreds of meters above sea level. I went through all that. And so here's a new mystery. The vast majority of Titan's lakes sit in sharp-edged depressions. You'll see a photo of this in a moment. They look like you took a biscuit cutter and cut out holes in the surface, and the lakes are surrounded by high ridges, hundreds of meters high in some places. So here's the sharp edge. You can see a plot from Cassini's radar, and you've got a sharp edge, then you've got the thing. You've got at the top a dry lake bed, and you can see the roughness of the dry lake bed. And at the bottom one is one of the lakes that are filled up, and you can see the level surface because it's got methane in it. But why have they got the sharp edges? That has been the question which the scientists are now working on. And they seem to be formed in the same way that karsts are on Earth. For example, if you've seen the Everglades in Florida, they've got just water dissolving away the rocks underneath. And it collapses and forms sinkholes. But the Earth karsts don't have sharp edges, whereas the Titan ones do. So there appears to be a retreat of the scar materials. Now here's, you can see down particularly in the bottom, you can see those sharp edges on one of those lakes there. So, if this is happening, the question now is how and why. Now, a new topographical map's been published. Remember that Cassini was only able to map about 9% of Titan at high resolution and about another 20 to 30% at lower resolution. So much of this is interpolated. So here are your maps there, and one of the surprises is that topography is less than had been expected. You know, the elevation, the changes in elevation. So there's nothing much higher than 700 metres, and it provides global views of the highs and lows of the topography. And two regions, the equatorial regions, are in fact depressions, which was a surprise. It's also a bit flatter than we expected, and the map suggests there's more variability in the thickness of Titan's crust than previously thought. Now, InSight, some of the things, missions coming up now. InSight, first launch chance is May 5. It's got a window for that. Hopefully the landing will be in November 26. I'll put the summary of the science there. Don't have time to talk about it much. And Mars 2020, you say, oh, hang on, that's not 2018. Well, the answer is, of course, that the body is being built in 2018, this year. So yeah, they're now building Mars 2020. And it's due to land, as you see, on 2021 in February. Something called the Deep Space Atomic Clock is due for launch in the middle of this year. And it's a technology demonstration of a small, extremely stable atomic clock, which can then, if it proves out, can then be used on deep space missions. The GRACE follow-on, and you say, hang on, that's not... Yeah, the Earth is a planet. So the GRACE is studying the planet Earth and following it, measuring its gravity field. And so it's going to be launched in the second quarter of this year and will follow on from the original GRACE mission. EcoStress is going to be launched and we go onto the International Space Station. And yeah, okay, that's looking at planet Earth. So that's a mid-2018 launch, and it's a high-resolution thermal infrared radiometer. The Compact Ocean Wind Vector Radiometer, again looking at the Earth, it's developed by the Air Force. Exact launch date, I don't know, but it's sometime during this year. And it's a microwave radiometer on a small satellite, not a CubeSat, but on a small satellite. Martian ice. Now, here's another scientific result that's come in the last month or so. Martian ice has been exposed at 8 sites. And the Mars Reconnaissance Orbiter, which is doing excellent work at Mars, has found this ice on slopes as steep as 55 degrees, which is, nice steep. And here's a picture of it. The scale at the bottom, some of you can't see the bottom of the screen, but it's 100 metres at the bottom there. And here you see that we've got at the top of the screen is the countryside, and then we've got the bluish looking area is where the ice is, and we're down onto a rock bed at the bottom.
So that's false colour, right?
That's false colour, but the ice is where the blue colour is. Okay, and so it's exposed the layers, and so we now have a look down at the icy subsurface of Mars, because large areas of Mars have got ice just below the surface. For example, remember the Phoenix lander landed and just scraped away. Oh, and they reckon that if Viking and so on had done that, just digged it a little bit deeper, it would have found ice then. Now here's the main picture, a kilometre across, and you can see this cliff that where they've found the ice, and they've found 8 others, or 7 others like that. Okay, you want to launch your design artwork on the side of the rocket, then you've got a chance to put your design on that. So there's a competition running at the moment to do that, and you've only got a few days left to do it, so be quick to put your on the payload fairing. It's a bit like Skymaster did, the NBN did with the Skymaster launch. All right, Cheops. Going to look at bright stars. By the way, this is what this design thing is about. Okay, and you've got until January 31 to do that. And it's on track for a launch at the end of this year. And it follows a 2015 children's competition in which the children are asked to submit artwork, and they have been engraved onto a plate which is going on the side of the satellite. And okay, you can't see all those pictures, especially if you're at the back, so I've done 2 enlargements of it. And each of those has been engraved with a laser cutter. Okay. So each little picture is a kid's picture. All right. Now, that's what Cheops is going to look like. And the idea is it's going to look for transiting planets. And Solar Orbiter is going to be launched by later this year. And it's going to look at the heliosphere in the Sun. It's going to carry 2 telescopes to just 0.25 of an astronomical unit. Now look, in the one article from the European Space Agency, the one official article, not by a journalist or something, they had 3 different distances for how close it was going to get. So one said 0.2 AU, one said 0.25, and one said about a third. So take your pick. I've just put the middle one in. And it's the first time. Now this is interesting because it's going to go into an orbit which will be inclined from latitudes higher than 25 degrees. Because of the way when it goes through that perihelion, it will actually be almost, you know what the word geosynchronous means? Well, heliosynchronous, if you like, with the Sun, and therefore be able to image the same area of high latitude on the Sun for an extended period of time, perhaps several weeks even.
So perhaps the orbit isn't circular, is that the reason why
It's orbiting the Sun, it's in heliocentric orbit.
Yeah, but I'm saying maybe it's not circular, that's the reason for the variations in the distance from the Sun that we were talking about before.
So
maybe the orbit is not circular.
No, it's an elliptical orbit.
Yeah, so that's why they've got the 3 different or the multiple different distances.
No, that was the closest to. There was They were saying that's the it would come to that distance of the Sun. Anyway, let's not get bogged down on that because I'm out of time here. And the interesting thing is, when it's doing this, it'll be delivering information on the other side of the Sun. So we've got a number of satellites here looking at our side of the Sun, and for a while, the NASA stereo missions are crossing over the back of the Sun. But this will be the first time that we get both sides of the Sun in detail. All right. One of the questions is, how does the Sun create and control the heliosphere? And it's got a whole lot of scientific objectives, which I've run out of time to go into. Solar orbital trajectory, launched this year. Cruise phase, it takes 3 years to get there. And during that time, they'll do some commissioning and in situ work. And gravity assists from Venus and the Earth on the way. And then the orbit around the Sun will be 168 days. Okay, so it'll be fairly close to the Sun, but it's not a circular orbit. And every 5 months, it'll come close to the Sun and back out again. At 60 solar radii, which is about 0.28 astronomical units. So I've mentioned there how it's going to be close. Now, James Webb Space Telescope was to have been launched in October of this year, is now delayed until 2019. And the reason for that is they looked at the schedule and figured out at Lockheed, we can't do this on time. So they had to advise the European Space Agency to provide in the launch 12 months ahead. So that's why in October last year they announced the delay. By the contract, they had to do it within 12 months of the planned October launch. Now, just to get an idea of the size of this thing, sun shield's 22 metres across and the mirror is 6.5 metres wide. So there's your sun shield. And there's the mirror, which has been built and shipped. They assembled it at Goddard Space Flight Centre. Now, Bepi Colombo, which Angelo mentioned, is a orbiter, 2 orbiters, and they are, what will happen is the Bepi Colombo thing together will deliver them into orbit, and then they will separate. And then the Japanese one will lower its orbit down lower. Okay? So it's based on 2 craft there, launched in October this year, and they'll use gravity assist on Mercury, Venus to get there, and solar electric propulsion. and they'll just one composite spacecraft on the way there. They won't get there until 2025. And the transfer module will then be separated, and the composite spacecraft will use rocket engines in a technique called weak stability boundary transfer to bring it into a polar orbit. Now, I'm not going to fully explain that, but I did sort of pull a little side track here, a little tangent. Route to the spacecraft. What is a weak stability boundary trajectory? It's a route that allows it to change orbits with very little fuel, just basically using gravity. And it was first tested with the High-10 mission, and as a result of a failure of the Hoko-Romo satellite to go into orbit, well, it may have gone into orbit, but communications broke down. So these two guys, Edward Balbruno and James Miller from JPL, had heard of the failure, and so they helped salvage that mission by developing this new technique. And now it's been used, a number of missions have used that technique. Right. So they should, remember that Mercury's close to the Sun, so it's going to get pretty hot, and they should last about a year. But there's a possible extension on there as well. I've got the column things there. Now, Chandrayaan-2 is from India, is due to launch in March, just a few months away now. It'll be a moon orbiter, a lander, and a small rover. Pretty ambitious sort of mission, and it's a combined mass of about 3.2 tonnes. Now, here's what that combined craft looks like, and the trajectory. Will be into Earth orbit, and then gradually a series of apogee raises until finally the moon captures it. Right. And then it goes down into there. So here's, it takes a fair while to get to the moon. So it's not sort of straight to the moon. And once the landing site is selected, it's going to be near the South Pole, probably between those latitudes there. Their landing will be entirely autonomous. So there's no one at mission control, sort of down a bit, down a bit, down a bit. No, it's, okay, that's where I want you to land, go do it. And it goes through a rough braking phase, and I haven't got time to do the rest of this. So it's an illustration of how it's going to come down. Notice the distance is downrange, 387 kilometres, down to touchdown at 0. And this landing, it says autonomously determined. It will then hover, and then look around and say, oh, I don't like that area, let's move over here a bit, and then touch down. And then from 2 metres, drop down. Now remember, it's not 2 metres like on Earth. Remember that gravity on the moon is 1/6 what it is here. So, you know, it's a bit like dropping from, you know, knee height or something like that. Not so bad. Then, a rover will roll out of the lander shortly afterwards. Now, they need to do it because this thing's not designed to last overnight. It will basically do it during the daytime, and then when night comes, it will probably die. Probably, but yeah, we've had histories of things surviving the lunar night before. So here's our little chug little rover coming out. And the orbiter is going to do a number of things. And here's the instruments on the orbiter, which again I'm running out of time to show you in the details. The lander, again, has got these instruments on board. And then the rover, it's got some cameras on board, but nothing facing the rear, like, say, the rovers on Mars. And it will use a small radio antenna for communication with the lander, which will then relay the data back to Earth. So here's a little diagram of the rover, and that's it under test, in a little sand pit. And the science done by the rover. So both of them to determine the composition of the soil. Now, InSight is going to be heading off to Mars, and it's going to do a bit of science. So I'm going to skip over this. Hayabusa 2 is going to be approaching asteroid Ryuga in 2018, June. And it has those things on board, which I discussed 7 months ago at a Space Association meeting. OSIRIS-REx is going to reach the Bennu in August. And collection samples will be in 2020 July and it'll come back to Earth in 2023. Now, sorry Angelo, it's Chang'e. Chang'e. Okay, and I have that from David Southwood, who is was the science director of the European Space Agency, and he did discussions with the Chinese about joint mission, and he said it's Chang'e. Okay, this is an interesting thing, because it's going to land on the lunar far side, which is only dark for 14 days of the lunar months, as is the near side. It will need a communications relay. So they're going to put a relay in halo orbit about the Earth Moon L2 position, which I will hopefully explain next month as to what that is. And that will maintain communication. So what will happen will be, if you imagine this is the Earth, this is the Moon, and like that, and out over here we've got L2. The Sun, by the way, is way over there. And so from the Moon, the signal goes to the little relay satellite and then back to Earth. Okay. Now, don't forget, and you say, hey, this is supposed to be 2018. This is not going to happen until 2019. But there's a flyby is on January the 1st, but the approach is on December the 31st and 30th and 28th. All right. There is a naming competition, it's closed now. I voted for Uluru. Thought that would be great. Here's the timeline for the approach in 2018 and the flyby on January the 1st. Depends on, your date depends on where you regard. Space things are supposed to happen at universal time. Now, this is interesting. Last year, when Alan Stern was here, and I had a discussion with him, he had just finished doing the occultation. Now, an occultation is when one astronomical object passes in front of another, like, for example, the Moon passes in front of a star. Well, the asteroid MU69 on July 17 passed in front of a star. And so they did a series of ground surveys and figured out when did this star disappear behind this asteroid. I'm going to call it an asteroid. Okay, it's a Kuiper belt object, but they found that it must have this rather interesting shape by the things. But they had done before flown the Sophia Airborne Observatory out over the Pacific Ocean and tried to do an occultation, and all they got was one little blip. And they thought, oh, we missed it. Even though the pilot did exactly where they were supposed to be within a few meters. Well, they missed it. Well, here's what happened. They think that the asteroid is there, and that little blip they got from the Kuiper Airborne Observatory was due to a small satellite, which is in orbit around it. So it looks like this object is either a 2S, well, let's show you the next picture. Maybe a double object with a satellite. So perhaps I should have suggested something like Uluru and Katatusha. All right. Anyway, that's the thing. Yeah, so what they got is a little blip way off here to the side, and they think that's what the Kuiper Airborne Observatory, I keep calling it the Kuiper Airborne Observatory, the Sophia Airborne Observatory saw serendipitously the satellite, and then the ground-based ones in Argentina saw this. So anyway, we are well out of time.
And yeah, I better shut up while I.
Thank you. Thank you. That brings the meeting to a close. And thank you all for coming out tonight. Sorry about the technical gaps and other things, but I hope you enjoyed the night as much as I did. I thought it was great. And thank you once again, James, for your hospitality and getting RMIT to let us come in here. We're going to have to get out fairly quickly. Our next meeting will be here or somewhere around here on the 26th of February. So put that in your diary. Invite anyone you like along. And once again, thanks very much. And anyone, yeah.
Sorry, Peter, just with Andrew's sort of acclamation to this as well, Andrew gave a bit of a spiel on the last space program about the upcoming eclipse, right? So if we can remind everybody about the eclipse coming up at the end of this month.
Lunar eclipse.
Sorry,
Lunar eclipse.
End of this month, right?
Lunar eclipse at the end of the month.
You gave a good description on the
Wednesday, last Wednesday of the month.
Yeah. So on the 31st of January,
31st of January.
roughly the time of the sort of like the big impact would be about, I think, 10:45, coming up to about 11:30, then till about 12:30, then it'll die out by about 2:10.
It's safe to view the naked eye.
Yes. Right.
So, thanks. Right, thank you very much.
A few of us are going to observe
Good night. Thank you very much for coming.
pointed surrender. A few of us friends.